क्या होना चाहिए इसका? Young doubles prefer ratio intensity of with this 4:1 and the ratio intensity of max to mean बोला है ना? Versus max to mean in the sense we can do like this. Like I1 plus I2 the whole square by I1 minus I2 the whole square. This is what I max by I mean. अरे यार कहाँ चला गया कुछ screen lock. Okay, so this one I1 maximum center freeze हाँ ठीक है हाँ, कुछ नहीं इसमें. So I1 have 4 times of I0 and I2 have times of I0. Just 1 times of I0. Simple. Add it and divide it. So that thing we can solve. So this is square root. So it will become 2 I0 plus I0 square. So this means 3 I0 the whole square. So it will become 9 I0. Then I mean this is what I max. Okay, then option directly we got it 9. No need to solve for others. Directly go for the option. 9 means option number C.
Sir, we can take the relation like amplitude wise also, na, sir.
Yeah,
So amplitude wise, if we take, then it won't come, na, sir. It's coming like 25:9.
but see what they gave here. The ratio of slits width, and this is what intensity is given. They're asking intensity, so we can go with this way.
Okay, sir.
The ratio of intensity of max to min, the closest is close to central fringe on the screen.
Okay.
Sir, I also got the same answer, sir.
So what? It's not correct.
The correct answer, what you said is correct answer, but I also got 25.
Oh, okay. So 9:1 is the correct answer, no?
Yes, sir.
Okay. You both are saying 25. Okay, so tell me what you did there. Let's check that way also.
1 minute.
Sir, Imax is like A1 plus A2 whole square, and I minimum is A1 minus A2 whole square.
Okay. I understood. Like, see,
So,
wait.
sir, I solved some questions in that way also.
Where is this relation? I wrote here only somewhere. I'll show you that relation. Yeah. So I1
Yes,
and
sir.
this one, they are under root. चलो ठीक है. Whatever. We can start your alternating current. This is a little bit bigger chapter and more important. So we'll solve more questions than others. Okay, let's go with some basic. What is? अरे बाप रे, इतना बड़ा. What is alternating current? Say. What do you mean by alternating current?
Changes
Changes what?
direction periodically is called alternating current.
Yes.
So it changes
Direction.
the direction of the flow of electrons
Yeah.
after every regular interval.
Now one question here, like theory, okay, fine. But practically, does it change? Like, okay, current goes here one time, then go here, then go somewhere else, or go somewhere else. Then how does we get electricity if it's changing every time? What do you mean by like changing direction?
So it's like changing the voltage, like low voltage, or we can increase the voltage or decrease the voltage.
Yes.
Like
Like,
it flows in, I guess, parallel circuit using which we can step up or step down the current, like we do
yeah,
with transformers.
correct. So actually, whenever we say like it's altered the what is it, direction, that means it is not changing direction. It is just going high value or it's going to the lowest value, highest value to the lowest value. It keeps changing. That is what alternating current. Now, actually, how does electron moves in that way? How does electron goes like, oh wow, I want to go highest value today. Oh wow, I want to go the lowest value. It doesn't. It's not like that. As we're drawing the graph like this, so how does electron move in this one? Like it goes. See, this is our wire. It's reaching from one point to another point wherever it is. So whenever alternating current, it goes here. This way. So this way it shows, okay, yeah, it's reaching the maximum value and reaching the minimum value. So alternating current what? Change direction periodically. And even like magnitude also. This may or may not. So it increased to 0 to maximum. Let's write here 0 to maximum and maximum to 0 in reverse direction. Then same way, maximum negative number and here 0 again. So next thing we can write here, what is the source? Source of AC. What is source of AC? Dynamo or oscillator. What are these things? We'll see that. So for just knowing alternating current, let's have one little basic. This sine curve and cosine curve. What is the difference between sine and cosine curve? Yeah. What do you mean by sine wave and cosine wave? Which of this is sine wave? Above one or below one? Aditi, Samhita, Shanmukh, Veda. Come on.
1, sir. Above 1, sir.
Above one is the sine wave. And below one,
Cos, sir.
cosine. Okay. So sine wave, what is the difference between those two? They both are opposite to each other. When sine 0 is 0 and cos 0 is maximum. When cos 90 is 0, sine 90 is maximum. You observe this. So when sine is maximum, cosine is minimum with 0. When cosine is maximum, sine is 0. They are opposite poles. So for alternating current, for any instantaneous value of current, I equals to I naught sine omega t. Now, okay, this is too big. Okay, what is I naught?
Maximum current.
Yes, maximum current or peak value or amplitude. Amplitude of current. Or, yes, correct, peak value of current. Or anything else? Amplitude, peak value, or maximum, as you said. Same way, alternating EMF. Yes. What is EMF? I just want answers from 11th standard guys. Oh, only one. No, two. Come on, Aditi, Madhusudan.
Electromotive force.
Yeah, what do you mean by that? Any idea? It's okay, right or wrong, doesn't matter. I know you're studying this first time.
It's like electropotential energy, I guess, yeah,
Yes.
produced by changing the magnetic field.
Yes, changing magnetic field. Okay.
Like it is
Changing.
generally used to convert one form of energy to another, like in batteries or generators.
Okay. Yeah. Somewhat right. Yes. Anyone else? Anyone? 12th grade repeaters. Anyone? What is EMF? Samhita, Shanmukh, Veda.
Sir, I have no idea about it, sir.
No? Okay. Anyone else? Samhita, Veda, what about you? Whatever it comes in your mind, like it's not like right or wrong. Anyhow, I'm going to give answer. Okay, fine. So I'm not going to give you definition or something like that. Let's see here. If this is the battery and this is some blah 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 things, whatever it is required. What's this? Data. Yeah, battery or whatever, like we are connecting. So we are saying current flows from here and ends here. Okay, fine. But how does this battery know that current has to be go here and whatever flow? So there is a force which is making them move. Electromotive force. That's a name it is like that. Electromotive force. So which make them understand, okay, yes, this is the place which is required, the battery, means current. So it will make sure the current is continuous. It is like a battery only. This force, like there is nothing like actual thing, okay? Force, whatever we are saying, even in real life, also we are saying force, nothing. There is nothing like force actually. It's just a feeling. Okay, yeah, we are applying a force. Yes, it's moving. I'm applying a force on pen, so it is writing. So like that. Same manner. There is a force which make these things. Okay, so there is a movement. We don't want to learn definition and all that here. Nothing required in your JEE exam. You just need to know what is it. That's it. Enough. Okay, so alternating EMF also we can write E equals to E naught sine omega t. Now we wrote both place omega omega. What is omega? Anyone?
Angular
Very good. Angular
frequency.
frequency. What is E naught? E naught is
Peak potential, peak EMF.
yeah peak value per amplitude. Or value of EMF. So let's draw here. If I extend this one more, this is T, then what will be this one? This is a T by 2. This is another T by 2. That means T. Then what will be this one? No idea? Okay, t plus 1 by 2 is 3t by 2. Simple. So on. 0, half cycle, and full cycle, 1.5 cycle. Next. Direct current. In this, see, magnitude may or let's say may change, but direction never. If I draw a graph for this, it's a 0 line graph. Time period. Current doesn't change the time. It may go up, it may go low, but it is not changing with time. Okay, so what is the what do you say? What is the like advantage of these two? What's the advantage? Something. No one? Very bad. AC is, let's say here, generation of AC is cheap.
So can you hear me? I was trying to speak since a very long time.
No, I couldn't. Now you can. Now I can. Then DC. AC voltage can be varied like this, step up, up and down. So AC voltage can be easily step up or step down.
AC current has frequency.
What about DC current?
It doesn't has AC has like frequency ranging between 50 hertz to 60 hertz, I guess.
Not range, but we can say yes, 50 hertz. For India, it is 50 hertz. Different countries have different ranges. 110. US has
Can
110.
be it can be transferred over long distances without any
Yes.
of energy loss.
Yeah, correct. Let's write that. Long distance transmission. Not without any energy loss. There is an energy loss. When there is a copper, there is a copper loss.
No, I said without much energy loss.
Yeah. Long distance transmission is possible. Then what else?
There are the magnets, rotating magnets which help in the change of electrons flow of electrons.
Yeah. But okay, what is advantage over DC?
Well, DC doesn't have rotating magnets, so it just goes into a single path, while AC can, using these rotating magnets, you can change the flow.
Change it. Flow, yeah. So we can easily step up. Without some loss. We can write like this: appreciable loss. What else we can say? One more point I'm looking for. Yeah, we can say this: conversion of AC to DC. AC can be converted to DC by rectifier, and DC can be converted to AC by what? This thing you're using here, you're using at home. What is it? How to convert DC to AC? You're using at home. Come on.
So from the transformers to the sockets.
Yes, transformer, but it is not DC, my dear. We're using it home. Home. Do you know something like starts with I and next word is N, next word is E?
Inverter.
Inverter, power inverter.
Yeah. Then I was about to give next more words. Okay. You're not so active, guys. Like, should we? Right, wrong doesn't matter. You answer. Because I'm not gonna judge you. Why right? Why wrong? Nothing doesn't matter. But for finishing chapter, you give wrong. Means that is not good. चलो ठीक है. So these are some silly points about alternating currents, or let's call it in good way, basic points. Now let's go into the chapter. See, okay, what in this chapter, main thing we need to focus on like RMS value. This is most confusing. Conversion of RMS value and peak value. So in questions, if it is given, those who already completed chapter, I know that most of you completed except two. So in this one, whenever there is a question, in that we will take standardly RMS value. Until and unless it is mentioned that this is some peak value or some other way it is mentioned, then only we will take peak value. Otherwise, it will be RMS value. There is a fixed thing we need to do. So what is that RMS value? Let's see here. Sorry. Average and RMS value of AC and V. Alternating current and voltage. Now, so if I want to find average value of current for this cycle, what is it? Come on, tell me. Here, let me give you some values like T. T by 2. What is the average value of this current cycle?
Not equal to 0.
Is it not equals to 0? Anyone else?
So is it like average of those two values T by 20? T by 2 plus T by 2.
It is actually 0.
Okay.
How? This is positive half cycle. This is negative half cycle. So T by 2 plus minus T by 2. Average value of current over one full cycle is 0, because this is positive, this is negative. So each negative half cycle has one on positive I naught and one on negative I naught. So it will be 0. So average current for half cycle of current over half cycle is equals to 2 I naught by pi. Same way, average value of alternating current, okay? Average value of current, no, voltage over half cycle will be 2 E naught by pi. So E naught and I naught are peak values. So let's do like that. Tomorrow we'll do root mean square value. I mean to say RMS value. Anyhow, sir will start the class. Okay, so in between itself it will be getting over. So better we stop it here.